Okay, so I wanted to do a quick video while I filled in my notes for you, just in case something didn't seem right from something else, or if my other video just didn't quite make sense. That hopefully, as I fill in my notes and explain them to you, hopefully it would make sense. So when we're looking for the interior angle sum of any polygon, our formula that we're going to use is n minus 2 times 180. So n is the number of sides of any polygon. Alrighty, so, and if you remember back from the other video, n minus 2 was how we figured out how many triangles were in each polygon, and 180 degrees is the number of degrees in a triangle, so then you just take the number of triangles and times it by 180. So n minus 2, again, n is the number of sides, times 180. So if I'm looking for the interior angle sum of a heptagon, we should remember, is 7 sides. If you don't remember that, go back and look at your notes. You've got it in your notes from the previous day. So I'm going to do 7 is the number of sides, so 7 minus 2, and then times 180. Now, I don't expect you to do this in your head, so you can pop over to Desmos or any kind of calculator and pop it in. If you are doing this kind of on your own, you want to do 7 minus 2 first, and then times it by 180. So let me start graphing. If I type it in exactly as I see it, it'll tell me 7 minus 2 and then times 180 is 900. So my interior angle sum of a heptagon is 900 degrees. Now, if I'm looking for the measure of one interior angle of a regular pentagon, we still need to figure out what the interior angle sum is of a pentagon. But then if it's a regular pentagon, we know that all of our angles are going to be exactly the same. So pentagon is 5 sides. So I'm going to do 5 minus 2 times 180. 5 minus 2 is 3, hence why I've got the 3 going on in there. So 5 minus 2 times 180. So if I just change out my 7 and for a 5, I get 540. Now, there we go. 540. Now, my question is, though, what's the measure of one interior angle of a regular pentagon? A pentagon has 5 sides, which means it also has 5 angles. So if I do my 540 divided by 5, and again, I can pop that into Desmos, 540 divided by 5, it gives me 108 degrees. So each angle in a regular pentagon is going to be 108 degrees. Example number 3. I have 1, 2, 3, 4 sides, which means we have a quadrilateral. So I need to figure out what my interior angle sum of a quadrilateral is. It's 360, and I can do that or figure that out by doing number of sides minus 2 times 180 is 360 degrees. Now I just need to add these up and subtract from 360. Or I can take that 360 and just subtract off all the angles. So 360 minus 75 minus 97 minus 105. And that equals, okay, so let me go to a second line here. 360 minus 75, 97, and I think it was 105. Yep. And that gives me 83 degrees. So when I'm looking for a missing angle, as long as I know what all the angles are supposed to add up to, I can add them all up and subtract from what the total should be, or just take your total and subtract off your angles that you're given. Last example. This is not necessarily as easy when you have variables in here. So what I like to do is